Hello, welcome to our review. Let's take a look at the first problem from the practice test. It says, which polynomial has zeros of -2, 0, and 7? So now we need to think about how can we make factors from zeros. Well, if you think back to earlier in this unit, what we did was we changed the sign of the 0 and put it with x. So this -2 is going to give us a factor of x plus 2. We changed the sign of that negative. This 7 is going to give us a factor of x minus 7, because that's a positive 7, so we change it to an x minus 7. This 0 is going to give us a factor of x, it doesn't really matter, plus or minus 0, because if you add or subtract 0, it's always going to be the same thing, right? If I added 0 to my age, I would still be the same age. So if we have x plus 2 here, that's going to stay x plus 2. But this x plus or minus 0, that's going to be just x. And then for our last factor, we'd have x minus 7. And then please remember, it doesn't matter what order you multiply anything in. So generally what we're going to do is put the monomial, the x term, the single term, in the front, and we have our binomials following it. So this would be x in the front, and then x plus 2, and then x minus 7. Great. Let's take a look at the second problem, which asks us, what are the zeros of this polynomial function, f of x equals 2x squared minus 6x minus 20? Well, that's a pretty tricky one to factor, especially since we have this coefficient in front of the x squared term. So let's take the easy route out of this. What we're going to do is we're going to remember that the zeros of any polynomial are where the graph intersects the x-axis. Here, here, and here are 3 zeros, okay? This is not this graph. So what I'm going to do is just go right to my calculator, and instead of having it be f of x equals 2x squared minus 6x minus 20, I'm going to make it y. And in fact, on the calculator, I'll make it y1 equals 2x squared minus 6x minus 20 graph. And the graph looks something like this. I've sketched up that graph from our calculator right here on the board. And as you can see, the where the graph intersects the x-axis is right here at -2 and positive 5. So those are our zeros, leading us to the answer of -2 and positive 5. All right. Please remember, do not write your answer like this, -2, 5. -2 is not the roots, because -2, 5 is somewhere up here. All right? Wonderful. Let's take a look at problem number 3. We have two functions that we need to compare. The first one, they tell us, is f of x, and that's equal to the quantity x minus 4 squared plus 6. The other function we need to take a look at is g of x, and the way they've given us the information about g of x is through a table. Be careful. This one trips up some people as they take it because they can't tell the difference between f of x and g of x. And if you look at the problem, they are kind of spread out. All right. So the things that we need to compare about these two functions, if we look at the multiple choice answers here, are we need to say, do they have the same vertex? So let's make a little chart here. Well, let's start with f of x. That's the most fun one here because there's actually kind of a little puzzle that goes along with it. If we want to figure out what the vertex, the zeros, the axis of symmetry, and we'll have to save the intersect at 2 points for a little bit later. But what I do want to do is take a look at the graph on our calculators of f of x. So I'm going to go right to my calculator. We've got x minus 4 quantity squared plus 6. If I hit the graph, we can see looking at it that we get something, a vertex up in the right-hand corner. So I'm looking at my table here, and I can see that the vertex looks like it's at 4, 6. For f of x. Now, let's see if we can see the zeros. Let's go back to that graph. This graph is way above the x-axis. I'm not noticing any zeros at all. So if this graph doesn't intersect the x-axis, then f of x has no zeros. Not that we could see anyway. Now, how about that axis of symmetry? Well, since we know what the vertex is, the axis of symmetry is very easy to determine. Now, a lot of people are going to look at that first value and say, oh, our axis of symmetry is 4. But be very careful. The axis of symmetry is actually an equation of a vertical line. So we need to have x equals 4 as our axis of symmetry. All right, let's hold on to that, intersect at 2 points. Let's take a look at the values of g of x as the values of x are increasing, the output values. It goes from -2 to 3, looks like it's going up. It goes from 3 to 5, goes up again. And then it starts going from 5 to 3, so we're going down for a little bit. If I were to sketch this out a little bit, looks like it would be going up for a little bit of time till it gets up to this 5, and then it starts going down as we move further along that axis, move further along our y values. So to me, it looks like there's our turning point right there, 4, 5. So that's going to be our vertex. So let's write that in for g of x. Our vertex is going to be 4, 5. Now, from this table here, if we were looking for the zeros, that's where our y value is 0, where the output is 0. They've got to be in here somewhere, but I'm not seeing any exact values for those roots. So not that they don't have roots, g of x doesn't have roots, but we definitely can't see what they are from this table. So I'm just going to write not available. Available. Here. So now let's move on to our axis of symmetry of this problem here. Well, it's really tempting to look at this 4, 5 and say that the axis of symmetry is 4. But we have to remember that our axis of symmetry is always the equation of a vertical line. So we have to say that it is x equals 4. Hey, at this point, we don't even need to worry about it. These two graphs intersect at 2 points. It's a multiple choice question. We've got the same axis of symmetry for both of them. Axis of symmetry for f of x is x equals 4. Axis of symmetry for g of x is x equals 4. They have the same axis of symmetry. Okay, all right, let's take a look at problem 4. All right, in problem 4, it looks like we have a parabola shape. It's upside down. I've gone ahead and drawn it up here, sketched it up here, and drawn our vertex right here. And as we can see, our vertex, if you look at the x-coordinate and the y-coordinate, it comes out to be 10, 20. Okay, that's really important, especially when we're going to want to put this equation in vertex form. So let's go with the traditional vertex form, which is y equals, and then there's an a in front, and then it was x plus the opposite of whatever the x-coordinate was. We square it, plus k. So it's a quick one here. We know that we need to have our a, if it's positive, the parabola would be opening up. Remember, if it's a positive number in the front and you feel positive, you make a smiley face. And if a is negative, you're feeling negative, you make a frowny face. So we've definitely got a frowny face parabola here. It's opening down. So this a in front is going to have to be negative. Now, I'm not even going to worry about what the value of a is right now. I'm just going to make sure that we know that it's negative. So it's negative something. Now what we're going to do is we're going to figure out the h value here. Remember, what we're going to do is we're going to take that 10, the x-coordinate of our vertex, and we're going to substitute that in. We're going to put the 10 here. And now it's a positive 10 here. So just remember, when you're inserting just the x part, we're going to switch the sign on the way in. So this, instead of being positive 10, we're going to write x minus 10. And now we're going to take that 20 and insert it right at the end because that's the y-coordinate of our vertex. It goes right here. We're just going to write plus 20 there. We don't switch the sign of the y value. All right? If you take a look through your answer, I forgot my square term here. If you take a look at your answers, 1, 2, 3, 4, notice that value of a was always the same fraction, 1/2. So it doesn't matter. Just choose the one that's got the negative value in front, and you've got minus 10 and plus 20 at the end. Great. Here's problem number 5. It asks us to find the zeros of the function f of x equals the quantity x minus 4 squared minus 49. Well, let's remember that thing about zeros. Zeros are just where a graph intersects the x-axis. So what I'm going to do is use a calculator, and instead of f of x, we'll call that y1. And we'll graph y1 equals x minus 4 quantity squared minus 49. And see where that graph intersects the x-axis. I happen to have it right here. And when I hit the graph button, I'm getting something a little funky. I'm getting it only intersecting at -3. So I know one of the answers is -3. I can see that that graph is intersecting at -3. But we know there's going to be 2 roots on this. There's going to be 2 zeros on this. Where's the other one going to be located? Well, I'm going to quickly go to my table. Here's what that table looks like. And I'm going to scroll through my table until I find that other 0. And I can see that on the table I'm looking at, it gives me 11. Because 11 is the x value, where the y value is 0. Cool. Now let's take a look at problem number 6. Problem 6 is asking us for the zeros of the function f of x equals x squared minus 2x minus 48. Okay, well, same old problem. The problem's so nice we're going to do it twice, or thrice even. We need to find the zeros. Remember, that's where the graph intersects our x-axis. So if we take f of x and instead we make that y1 equals x squared minus 2x minus 48. It's a very simple problem. You graph it on your calculator, and you can see that the graph comes out something like this. I'm just going to sketch it. And if I count over there, I get -1, 2, 3, 4, 5, -6 over here. And then for my positive x value, I get 1, 2, 3, 4, 5, 6, 7, 8. Looks like the zeros are at -6 and 8.